And welcome everyone to yet another week of the MonoGame University. Here we're going through the 2D tutorial, going through, look at all the different tricks of the trade as we try to impart in all these tutorials, show you how to build these projects properly and also things to watch out for. And a nice little caveat, I've got an extra sort of, I don't know, extended section at the end of this one because I prefer to do things my way. But anyway, if we look on, so what we're going through today, obviously we're going through the course. We're up to chapter 7 now. We're starting to sort of optimize textures, looking about how we're sending graphical data to the graphic card and how best to order and look at it, and how, more importantly, how graphics cards work, but with the way they work with textures. We'll go with some Q&A and we'll do some extra stuff. As we try to kick off each session is now, we're trying to highlight what MonoGame's doing these days, with all the contribution support that we get is that, we're here now every week. So I'm here with the university going through different tutorials, showcasing what's coming up and trying to do more when we can. And Tom is hitting us every Friday with deep dives into technical fixes and rummaging through the code and also showing how Tom's brain works when debugging things in the framework. It's quite to point out, we started at the open hours last week now, where we're showcasing now some of the new 3D content that's coming soon. It's going to be available to sponsors initially for a period of months until everything's been checked out and they've got all content, then they will eventually go public. There's no intention ever to withhold things with MonoGame. There's never going to be license fees, no runtime fees, no costs or anything else. All that we ask is those who are helping us out and sponsoring us and helping making MonoGame what it is today, they get first stabs at the stuff that we're paying for. We're also dedicating a lot of time to doing. So the first one of that is the mobile deployment guide, which is taking your MonoGame game, like the 2D tutorial, which is what it's based on, and then restructuring it, adding in things like touch support, how to then package it for the different platforms, how to get it published, and all the little gotchas that are going on there. We've also got the 2D shader tutorial, and there's an extra thing. If you've seen the shorts that we've been doing, I did a nice little recording as I was finishing up reviewing one of the final chapters for this, which is really nice. But it goes to all the different kind of shader effects you can add to 2D tutorials like this. No doubt we'll get another bounty up for when we get to 3D or dream more even. And as well, we've got the 3D beginner tutorial, which is teaching you everything to do with 3D, like the 2D tutorial does, showing you all the different funky things you can do, how you build things. With 3D, it adds another level of complexity. So once you've completed the 2D tutorial, we highly recommend you then would move on to the whole 3D realm and worry about depth and projection matrices and 3D collisions, which just added that it adds an extra axis of depth that you need to worry about. So with the shaders tutorial, we can show something here. Is that here we're starting off with a basic scene. Now, what is really good about the shaders tutorial is that it's got a hot reload system, which shows you how to build, which is fantastic for building shaders. So on the left-hand side, we can see here that we're showing the constant building process going on as we change shaders. We have the shader code in the top right, and down the right, we've actually got a deferred render, which is showcasing and showing off what you can see. So we've started here by adding a basic light. You can see it's just represented by a little blue square there. And as we move on, we're going to then add some extra code where we're going to add some scope to the light, but obviously at the moment it's kind of inverted, so you can see like the recompile is going on, the shader updates. And then we're going to sort of invert that light field so that rather than being a outwardly lit element, we're now inside lighting from the inside and out. And then obviously in case, we need to add things like brightness so that we can then control this through a shader, adding in the ability to then have a nice little slider as it recompiles there, and they can go and change the luminosity of that. But obviously then we need more in that. We need to add like sharpness or saturation so that we can control not just like the effect, but what the reach and the way that light works. And the tutorial goes into great length of showing how these work. And then obviously then adding also fall off. So we've got a tentative light, but obviously then the reach of that light needs to fall off as it affects the scene and how things receive light. And just lots of things in there. The tutorial works you through all of this, showing you how you build these things and how you can do it. Then last but not least is we also then we need to color. So we want what different lights are different colors and how they're going to affect. And then once this is complete, it shows you then a representation for how it would look. And I shouldn't switch out content like this in the middle of a scene, but let's have a look. I've got the video which shows the final representation of this. So here we are. You can see the demo running. So we can see how there's actually several lights which are moving around the scene. There's lights coming from individual elements, and if we I'm terrible playing our own game, which is funny, really. And there's several lights for each of the different torches and things like that. So it's a lot of fun. But anyway, enough about tutorials. Where that's one tutorial that's incoming now. That's what everyone's going to be able to get access to. Sponsors first, then everybody else. But to get there, we need to get through what we've got. So we're starting off with the 2D tutorial now. And let's see if we get into the actual weeds of this now. I've got the wrong screen up to start with. So, hey, we're in MonoGame. I love looking at our homepage because we keep adding new content and projects keep coming up, showing you all the built with MonoGame titles. You can see all the different things you can do in there. But anyway, we're here to learn. So let's get started. So obviously, as we say every single time, getting started, nice big button at the beginning of the screen, and we're straight into the building your first 2D game. As more tutorials come on board, they'll be available here. That's like the advanced ones coming up soon and 3D, but we're here to get started. And we're up to now chapter 7. We've come a long way, and I will take one step back originally, which is why the screen was up there. So, which is now why do that? Where we kicked off last week, we ran into a small issue where if I run this project now, import my Solution Explorer, I shall debug, start new instance, and oh no, why is that not working? What have I broken? I think I know what I broke because I've been playing. So go to here, and I'm going to remove that and remove that because this was the sneak peek thing I was playing with, and I'm going to undo those because I want to keep those back. Right, let's just try that again. This is what I get for playing. No, why am I not building now? This is right. Okay, so what's going on here? There's my content project. There's my MGCB. I'm going to open the editor, which is good. Again, over on the screen. I'm going to build this. Oh, right. Okay, so it's still exclude from project. Save. Build. Right, that was right. So this was my thing. I did an extra bit at the end of the tutorial, which we'll go through. And right, okay. So now debug. There. Now my content's building. But it's always good to go back to your content project. If you get any build issues or what's suddenly doesn't understand what's something working, open the editor, build it. And here we are. So this is where we are last week. And we couldn't explain this because the code didn't make sense. So we've got one texture here drawing because I threw it to the end for fun, where it's drawing at the center of the screen using the code that's in the tutorial. But when I'm building these content and how they're going to work, I prefer to use actual variables, actually going to control what these things are. So I'm not currently having to access or source where these things are. Sometimes you don't know how the accesses to these functions work and things. So it's always better to use a strict local variable, pull the values from there. But this didn't make sense because I was calculating the screen center, I was calculating the center of the texture, and these should have been the same. But as you can see, it was not. And the answer was actually a really good learning exercise here. because the reason it was not working is because I was actually querying the size of the screen too soon. Now, when a MonoGame title initializes, we constructed the whole framework, we created a window. But when you initially create a window in any kind of framework behind the scenes, it's generally small. It's not full screen. It's just the initial initialization of how the screen looks. And we then get to work of saying, right, well, you've said that the default size is this. This is what the size of the window is. Is it full screen? Is it showing your mouse and things like this? Which, if we look down here from the way we've constructed it so far, our core class in the MonoGame library is what initializes everything. So we can see here that, let's see now, we load the core and we say, right, we want it this width, this height. Do we want it full screen? And this goes initialize the graphics driver. It initializes all the graphics interfaces at the point of construction. So then when we get into a game, okay, so we're saying we want to launch a window, it's this size, and it's this, and it's not full screen, so it's fine. So that's what's constructed. Then we get into the initialize phase. Now, initialize is not instantaneous. It takes time to reserve resources to tell the graphics card to draw in these dimensions. And there's a few arguably frames that you don't generally see because this happens in the background when this initializing. And we're getting the screen at this point of time of when the graphics card has been asked to initialize. So it's at its own size, not in this one. So effectively, we're actually getting the size of the screen too soon. We've not worked out what the size of the screen is. There's two ways to handle this. We can either have a method here which goes and listens to the graphics device manager presenting property. There's a method event called graphics presenting or something like that. And we can listen to that, and then once I initialize them, we can go and get the screen. It's far easier to simply move this down to load content, because load content happens a little bit later. So at this point, the graphics card's ready, the environment's ready, it's set up, your file system's ready, and the content system is loading. So as we're loading the content, the actual logo, getting it there, we just get the screen here. And just by moving that one line a little bit later in the initialization, if I go and run this now, he says, watch this fail on screen, as these things do. And the screen's going to go over here. There we go. There we go. Now we got both of them drawing in the same place. So as we would expect in this, we've got the screen center, we've got the logo center. So drawing in the center and drawing the center is the same thing. So I was amazing how that perplexed me so much. But anyway, that's just a recap. Let's go back to the subject of the day, which is texture rendering. Now, it's important to note that even though we have sprite batch and that efficiently works about how we're going to load textures, we talked about filling our bucket and then sending it all over to the graphics card, but still, the order that we do this is important. And this is something that tutorial goes into a lot of depth through, where if we said, right, if I've got a Pong game, so I've got a paddle on the left, paddle on the right, and the ball's going to be bouncing between them. And your mind would go, right, well, I'll start with the player's paddle, it's over here, then I'm going to draw the ball, and I'm going to draw the other paddle over here, which sounds okay in principle. However, what this effectively means is that you're taking the texture using the paddle, drawing that to the screen. Then you're unloading that texture, swapping it, and then giving it the ball texture here in the second call. And then when you're going to go again, you're going to say, all right, okay, then you need to unload the ball texture, and then going to load the paddle texture again. So you've taken one texture, passed it to the card, pulled it back, sent the ball texture, passed it to the card, pulled it back, and then gone back and again do the paddle texture again. So you're doing a lot of what we call texture swapping, which we're putting textures into memory to do processing, then pulling them back out again. This conserves memory about how the GPU works in drawing. Now, the simplest way to then handle this is that, well, don't do that. If you've got a number of texture work, draw everything you need with one texture. So we're going to, in this case, for the kind of paddle game, we draw the left, we draw the right, Then we go and swap the texture and go and draw the ball texture. So that makes it a little bit more efficient. But we've still got 2 textures involved here. So I'm still, even though it's a simple game and what I'm drawing on the screen, I'm still drawing multiple things. Now, if you recall back from last week, one of the effects of Sprite Batch is that we can actually do regions. So instead of saying, here's one image, go and draw it to the screen, I can say, right, well, here's my image, draw this bit, then draw this bit, and take those, draw them in these different places. And we did that with the actual logo. So we cut out the logo, we took out the text, and we drew it in different places on the screen. Look back like last week if you missed that. Let's just see if there's any questions. Oh, look at that, chat's alive. We'll take a quick pause. And yes, I am desperately working. You would not believe the amount of work that's involved in make sure you got professional production on content and tutorials. I mean, I've wrote books, and those can take up to a year just to write, and then you got to get them published, and then you spend your next 3 months cursing at the publisher because a framework uses something written in English they're doing for an American audience, and they remove all the U's in print. Such fun. As to where shot, if you're going to start, the best place to start is where we are. Well, not where we are today, because we're in chapter 7, but either go back and watch the previous sessions on the recorded sessions. If you prefer video, we do a lot of chatting, questions and queries. If you prefer it written, then just go to the 2D games tutorial. So, go to get us started, start beginning. This tutorial has been manufactured so from beginning to end, from your blank computer to everything installed, getting the tutorial running. This has everything for you, and we're running through this in the live shows every Thursday, which is advantageous because if you've got a question when you get to a chapter, you're like, well, I'm not really sure about that. Where do I get the question? Come here. And it doesn't really matter which week you ask, as long as you get to it. You can always get online, you can ask, and you'll get an answer. And then everybody, right. Yes, I have stuff. I have games published. I've got books published. I blog regularly about different things. Some about for MonoGame, some for Microsoft, some for other things. Basically anything I find cool. I love education. I love teaching people. I love showing people how to do stuff. And also, as you see here, I show you how to break things. But anyway, back to where we were. So, yeah, well done in questions. Right. So, as we described, the better way to handle this now is to reduce the amount of textures you send to the graphics card. Now, this is a trade-off. You might think this is the one solution for everything. I'll do everything in one, where we take all the individual things we want to draw, we put them into one texture, and then we just send that one texture up to the graphics card, and we're just picking things up. We solve the issue of like popping textures in and out of the graphics card and what we're going to draw. Should be fine. Yes and no. So while this is a good technique and it's a good way to be efficient about what you're drawing, you still have to be intelligent and clever about how you're drawing and what you put onto the same texture. So you shouldn't put all of your game's textures onto one sheet, which ends up like an 8K texture which you're sending with the graphic card every single time you draw. There are little techniques you can do to reduce that, but in principle, you're sending up the same texture each time. The better way is to do it, case of, right, well, I've got my game menu screen. Right, all the menu screen textures I'm going to send up in that go while I'm on the menu. Once I get to my game screen, unload the memory textures, and I'm going to load my game textures. If you've got different levels and you're flipping between levels, then you might have a texture per level with one texture, which is all this common stuff. There's lots of different ways you can chew this up, and it all comes down to what your game is and how the architecture is and how you're going to do it. But in principle, it's a case of you take one image, you put on the textures the images you're going to draw in the same texture. What's generally best advised as well is that you use this in a kind of a uniform way. So it makes it easier the later then when you're trying to break up that texture for the drawing, is that you know what the bounding areas that you're going to draw. Leave yourself enough free space or transparent texture around it so that you're not going to have colliding sprites. There are techniques you can do to dynamically assign things. So things like Unity and Unreal have ways of saying, right, well, the texture is here. They create very boxed regions throughout the R, but all you really do is make more complication for yourself, and then you suddenly get the next texture where you actually need a bit of alpha around, or a bit of glow around a bit of an image that's going to get drawn to the screen. And it creates problems if you kind of have these tight nested groups of how you're going to pick it out. So my general advice is keep the squares. It's the best, it's simplest and best way. Don't worry about too much white space, because white space is almost free. Alpha in an image is 0. It's just a pixel byte on the actual texture. There's no color information, so it's very flat. So as we go off here, so here is case of from taking this example now where we've got our one texture, which is the actual atlas. So the entire texture itself, that's what we're going to load in the content pipeline, what we're going to load at runtime. Then we simply define the regions, which say, right, the paddle is this big, the circle or ball is this big. And then that's all we're doing in code, is that then loading the texture, we're setting the rectangle, and then when we're drawing, we're sending up one texture every single call. And we're just saying, right, from this area on the texture, draw it here, and this is the tint of the color we're going to do, and then repeating that for the rest. And then it's a lot simpler, a lot more efficient, a lot better way to organize how you're going to draw things on the screen. But obviously, if you're just doing it like this, it can create problems, because what if I've got 20 textures on the screen? It's fine, I've got to manage what's on here, or different ways of doing it. So what we can do, or what the tutorial does, and we'll switch over to code now, is we're going to define classes which are going to manage this for us. So something which says, right, this is how I draw an area of a texture. And then another class which says, right, from this atlas, this image, these are all the regions that are defined. That allows you to, if you need to, you can have different regions without making things complicated. And also, the tutorial has a good way of working through of then having a way you can do this not in code. Because the problem with code is, in case of changing it means you rebuild the entire project, where you might want to just say, well, I just want to put in, I want to change the image and then change what the region is. It doesn't change the drawing, but it changes what the source image is that you want to put into it. So it's better to handle this with code. So move things into content that are dynamic and changeable, and in code, you're just drawing what the configuration essentially is just telling you to draw. So let's bring up the project. Where are you? Okay, so we're not going to need half of this now, but we'll clean up as we go and make things a lot easier. So we are going to create a new texture region class, and this is going to see. Look, okay, I'm copying from here. The texture region. I'm going to go down here. We're going to put this into our library project. For those who are just joining, the project is structured in a way so that I've got reusable code that I might use on any game. And then you've got the specific game code just in the project itself. There are ways to also break that up a bit more, so that if you find that you're going down the multi-platform route, then you'd also want another library, which is the shared platform code for this game. So it's like you would have a library, which is all my common code. That'll go from game to game to game to game. Hopefully you want to try and put as much into there as possible. That allows you to reinvest or reuse code that you're going to use for all of your games. Because obviously we're not here to build one game. We want to build many. And then you'll have the game's own specific library, which is, this is stuff common to all the actual game itself. And then when I have the platforms, hopefully you just want to have the slimmest amount of code in there. All the code runs from the game library. All the shared stuff comes from the actual shared library. And you make our life easier. So in our library, I should have done around there. That's the Explorer view. Let's collapse that. Although my pet's getting bored. Let's go and who are we? Let's add a new pet. I shouldn't add a new pet every week, but here we go. Is Black Clippy going to show up? Oh, what? Oh, buddy. Give it a name. We are. Clippy has entered the scene. Let's give them a ball. Who's going to catch the ball? I don't know. I digress. A bit of fun. So in our game library now, we're going to start organizing our code a bit better now. So we're going to create a folder called graphics, which obviously we're going to put any code related to graphics. And then I'm going to create this new texture region.cs class file. And we've got a nice starting bit of code here. So here we've defined the class that we're going to run. We're also defining namespace. Now, namespaces are also extremely useful in code because it allows you to organize where things are. So while this is in the MonoGame library graphics folder, the namespace basically says it's MonoGame graphics library. So then when you need to look for code or trying to find stuff, you know where it is. You don't need to go searching or, okay, where the hell did I put the texture region now? Let's go, where is the texture region? Oh, it's the classes there, looking for it and finding it. Make life simple for yourself. Name things, group things, and then use namespaces in code so that both code and in your folder structure are the same. It saves you a ton of time. But anyway, so we got our texture region class, and we want to add some properties to this, or members, where we're defining what a region looks like. So we've got a texture. Obviously, we need an image that you're going to identify where you're going to get something from. You're going to identify the source rectangle, so where on that image you're getting the data from. And then we need, it's also useful to know within that source area what the height and width we're going to pull out from. This is just information we can use in the project when we drawing things. I'm getting sound of water in my ears. It must be the music. So, obviously, with a class like this, it's very, very simple. There's no actual constructor, but we'll have a way of then defining what a region is by passing in the texture reference we're going to use, its size dimensions, and then its width and height. So that means that we can say to the region, here's the texture, you as an image are responsible for this bit here. But this is just to help the class to help us work on things. And also, it's all then very useful. If we're keeping things contained, what you find with code is that if you can keep code related to a specific thing within the class for a specific thing, it makes your life a lot simpler. So if I need to draw this specific region of a texture, then tell the region to draw, rather than trying to write some more complex game code. I'll go over here and say, right, well, it's this, so I need to go and do something else. Again, make your life simple and just put things where they make sense. So if I'm setting up a region, all the code within the region class. If I'm going to draw the region, it's in the region class, and so on and so forth. And utilities are going to do that. Also, there's two what we call overloading methods here. So we define one method called draw, which takes the sprite batch, position, color, rotation, origin, float scale, some effects, a lot of things. And then we've got what we call an overload, which is the same method, but more importantly, it has a different signature. So it has different properties. So let's see, what's the difference in these two? Sprite batch, position, color, rotation, origin. Okay, so this one has scale is defined as one value, and this one has got a vector 2 as a scale. So it gives you different ways to draw things. You can have as many. There's no limitation on how many of these you can have, except that they must be unique in their signature. But also, don't kill yourself and don't overdo it, because the more you have, the more confusion you can have in how you're structuring and using your game. Right, okay, so that's sort of the texture region now. That defines one region on a texture that we're going to draw something. So if we look at that paddle example, can we get back to here? Yep. So we look at this paddle example, I can now define two texture regions. So this is the texture. It's the same texture for both regions. That's region 1, that's region 2. I've got two definitions, so that if I need to draw a paddle, I just draw the definition I've got for the paddle. If I need to draw the ball, I can draw the definition for the ball. Onward. No more questions yet. So So to surround this, then we need to actually describe what we're doing with our atlas, which is like the sort of the master image we're going to use. So that ensures that we only ever load the content for the texture once. We don't want to load it every time we have a region. We just want to load the atlas. And then within the atlas, we're going to say, right, I've got 2 regions, or I've got 6 regions, and then this is how I can draw them and keep references to what those are. So again, within our graphics folder, I'm going to create a TextureAtlas class file. And the tutorial nicely comes up and puts in the default start of this. What I also like as well in the tutorial is that when it sets up a new class, it gives you all the using statements. Using statements are basically a case of what does this class need to know to work. So go and look at collections. Go and look at these XNA libraries. Don't worry about link. That's a funky one. And within this, the only member we actually really, well, not the only member, but the primary member we need, obviously, is the texture. But we're also going to have a dictionary for the regions that are in it. Now, dictionaries are a very useful collection. And whereas normally you just have a list, which is just a list, a collection, a list of things, a simple collection, a dictionary is useful because I can actually look up. I can say, right, this entry has this name, this entry has this name. So instead of having to keep going through the list and searching for the item I want, I can say, right, well, get me the bowl, get me the paddle. It's fast, it's efficient, and its only drawback is not serializable. So when you want to write a dictionary to a file, you end up having to split it apart because most serializers don't understand dictionaries. There are ways around it. That's generally not worth the effort of doing it because what I find is a dictionary is good for runtime, for doing things. For data storage, you generally want to handle it a different way, and we'll show some of that. Okay, so when we want to go and create a TextureAtlas, here we go. So we've got the basic constructor, which is just create me an atlas. There's no image, nothing to know here. That's it. Or we have an overloaded constructor, where we also can say, right, well, create me an atlas using this texture. And then it creates the default regions. A good thing to watch out for is that if you have a class with like a dictionary or some kind of operator which can be null, generally speaking, now I would actually go and initialize it here, so that every time I looked at that, it would always be there. If you didn't have this and you then tried to access what this property was, it would fail and come up with a nice, horrible runtime null reference exception because I've tried to access a property or something that's not initialized, which is why we always have these new statements here. So we ensure that if we're creating new, we set a new dictionary, or if you're passing a texture, we also make sure we initialize that dictionary. So any way we access the regions later is managed, and we're not going to crash because null reference exceptions are bad, even the best of days, even when you handle them. All right, and so as for the next part, then we need to have some ways to interact with this. Oops. There we go. Let's get rid of the debug window. There we go. A bit more space. So then on this, so once we've got a class, it's been initialized, our atlas, we then got some methods then for manipulating or working with it. Now, method access to classes is extremely useful, especially when you want to control the data in the class. So you'll notice here that this property is private. No one can see it. No one can do anything. It's only known to the class. Whereas this texture is public. So anyone can see it. Anyone can even set it. So I could just do a new TextureAtlas and then go TextureAtlas.texture set or equals. But the danger in there is that I find personally is that if you have a class that's managing something, that you manage the data within the class itself. You don't have those public external properties because something could change it without, or you could accidentally change something without realizing it. And then you're wondering that why at this stage of the game, well, why is this set to this? Because it shouldn't be. It should be set to this. But some part of your code has gone, oh, just update this. And if you just allow public accesses like this, They can. I mean, generally speaking, I'd go private set, which means this is an auto property, so anyone can get the texture, but only methods or code within this class can change it. Hey, Dino, welcome to the show as we delve through this. But anyway, I'm not changing the tutorial because Chris has set that to a reason, and I'm going to leave it alone. But obviously, nothing else can see this dictionary. So we then have methods to control access to these elements. So if I want to get the region, we're passing a name. And then this is dictionary lookup code to basically say, right, whatever's registered in the dictionary, get me the result of that from this name. It's a good way of doing things. Yes, Mike, I am a big proponent for encapsulation. Everything has a job and it should do it well. It's more important as well when you start to look at service architecture, which is next level. That's a bit beyond from a program perspective of what we're doing and everything else. So we're in there. Yeah, we could change this property to a nullable property. I generally stay away from nullable. It's a good way of doing programming. It makes things safer, but there is an overhead, like with anything else. And also, you have to be aware that if you're then going to target consoles or other platforms, they might not support nullables, depending on what their .NET framework is, how they're doing things. So you have to be careful. And I'm just going to turn off my heating because it's got warm in here. It's cold earlier, now it's warm. But anyway, well, I digress again. So to this, we're having several method functions, which are actually functions that work with this. So we know that we ask for a region, that's defined here, by its name. And then we're going to get back the region definition. So I will get a region. I can then go region.draw or region.update or add. But then there's other methods here. So I can remove a region. I can clear all the regions, or I can go and load the regions from file. Now this is, I take not effect, but we're going to do this better later on. But here at the moment, we can pass it a file. So we take a file from the content space. We're going to read that file, process it, and it's going to do things within it. It's going to populate inside the class. So the outside of it, don't know. It's working on populating this atlas with all the information it needs from configuration. So we can add, we can get, we can remove, and these are good ways of interacting with the class and how we're doing it. So where are we going? That's moving the way down. So we've now got our atlas defined. We've got our regions defined with all these things in here. So we should really go and add in some data now in the tutorial. Go back to here. We have a basic atlas going down. Here we go. And it's a bit hard to see it, but if let's see. I want to save this image. Okay, let's put this into university, and I'm going to put it into where we're asking to put it, into our content project. So in here, content, I'm going to put in a textures folder. I don't think the instructions do, but it's a texture. It should go in the texture. And if we open this, so we can see it a bit bigger. Of course, we're on the other screen. And in here, you can see this is the same representation as we do with the actual ball and bat. So here we've actually got animations as well. So where I've got one texture which is actually a segment along, so we're actually going to animate these two elements. So I've got frame 1 of the slime and frame 2 of the slime to make it bounce, and then we got 3 frames from the actual bat as well. So when we get to full animation and doing animated sprites, you'll see more of this. But I've got an atlas. I've got 5 regions here. They're all going to have different names, and this is what I'm going to load. So obviously, this is only half the journey. I put it in today. I'm looking forward to the day I don't need to do this, but we're going to go. I'm going to open our content editor over here. In our textures, I'm going to go and add an existing item because it's a file that's in the folder, and then open the atlas and add a link to it. Save. And as I usually do, I build. Nice and good there. And let's close that so it's all working. Close that again. So now I've got my content in my content editor. I've got my code. So we actually want to go and then start loading this. Right. So over into our game class. So right at the moment in this project, we've got our game classes in our game project, even though we do have shared code down here, but I'm not using that right now. And we want to add a reference. What very important here is that we need to add a using statement in, because we've added our texture code into the MonoGame library project, into the graphics folder. We also gave it the same namespace of the MonoGame library graphics, so we can find it in the same way. And then we're going to go and declare to texture region. Let's see, we don't need that logo anymore, so we can get rid of these. There. So we're going to have a texture region for our slime, which we saw in the image on our bat. And then we're going to go and load it. And we're also going to get rid of some of this other stuff here, so we don't need those things anymore. So here we're independent, we're loading the Atlas texture. And we're going to create a new Atlas. We're going to add 2 regions, one for the slime, one for the bat. And then we're also then going to get, once we've loaded that into the Atlas, we're going to say to the Atlas, right, give me the regions for what is the slime, what is the bat, and then so these are then things I can then draw or do something with. And then we'll go down to draw. I'm going to rip out a load of code now because we're not doing what we did before. So there's all the stuff. We don't need all that. Okay, and give it a view. Obviously, we have, again, as we covered in previous sessions, so you always start with the sprite batch begin, which is preparing to draw. And then we sprite batch. Look at this. Intelligence is trying to be clever, but I'm going to go with what I've been pasted from the tutorial, which is slightly different. And oh no, this is including because we can get rid of begin. And can get rid of and didn't notice that was already in there. So we've loaded our texture atlas. We said in this atlas we've got 2 regions. So this is a bat, this is a slime. We're then going to say, right, we then loaded those actual regions from the atlas. So we got this texture region definition, which has a draw call in it. Again, lots of compartmentalization of how we do things. And then back in our game, then all we simply need to do is say, right, well, draw the slime in this space and draw the bat in this space. Oh, hey, no, okay, so this is why I like having an audience. See, I was planning on building and running that and not working, but yes. See, images, atlas, and content. Yeah, we're in textures. Good point. We could have failed. You could just let me fail there. That would have been brilliant. It's a learning exercise, because if you type this pathing wrong, it won't work because it's going to looking for the images folder where we're in a textures folder. So I'm breaking the tutorial already. It's not case sensitive, so you don't need to worry about that. There we go. Thank you for that quick call out. I'll come back to this in a minute, John. I'm not ignoring you. But anyway, we've got our atlas. We've initialized our new texture atlas based upon this texture. And then added the regions to say, right, in this texture atlas, I want this, the slime is this area, which is starting at 0, 0 for 20 pixels and then 20 pixels. And then for the bat, it's 20 pixels long, starting at 0, so the top. Remembering, again, images in MonoGame, the 0 coordinate is in the top left. Always in the top left. Top left of your screen for a 2D screen, top left of a texture for a texture. Then we said, right, once you register them, right, then get me the reference, the texture region reference for the slime. Same for the bat, because we registered it with the name. We're calling it back for a name. Again, this is where dictionaries are really useful, unless they start to have hundreds of thousands of entries, then they're not. In different ways of things. And then because the texture region has its own method for doing draw, it simplifies all the code we need to do for drawing a texture region. And we just need to give it the batch, where we're drawing it, how it's going to be scaled and all this. And then now we should be able to run this. What are we betting? Is this going to work? Debug, start new instance, or is this going to come crashing down? Where are we going? Come on, it's going to be on the screen. And there we go. So we've taken the textures here. So we've drawn our slime, and we said to draw it to vector 2.0. Wait, that's going to go off the screen. So we're drawing. That's drawn from the top left-hand corner. That's where it's drawing it. And then we said, right, well, the bat, the width, whatever the width of the slime is. So I'm moving the bat along by the width of another texture. So it's a way of dynamically saying that if I resize the slime in the texture and I change its region, then I don't need to change this code for drawing the bat, because it's always going to be a bit further along based on something else. Using representative logic for how you're drawing things is quite crucial. It's a trick you will learn over time, so that you don't just say, right, well, here's the 0 between, right, I want to draw this here, this here, this here, this here. Because what happened, I've got it turned off. What happens if the screen is a different size? Well, suddenly everything's off, because everything's drawing to the top left corner. So because the screen's bigger, I'm not using part of the screen. Some point later in the tutorial, we'll come over about having what we call resolution independent drawing, so that you're not always drawing to a fixed coordinate. You're working out, well, this is the size of the screen, this is how I should scale my textures or not, depending on your game. You might want to keep things tiny, but have a really big background. But never always although it's useful here to make sure that, yes, if the slime is always going to be drawn next to the bat, use the current width of the bat as an example of then where to draw the slime, where to draw the bat, and so forth. So, great, but at the moment, this is all in code, so this is not really manageable. So if I want to change these textures and just change the region how they're drawing, my drawing code is still going to work. So it's always going to draw the slime in the corner, and then it's always going to draw the bat next to the slime, however big the slime is. But if I want to change them, that means then I've got to come back and start changing code and rebuilding my text instead of just, I want to change my content. So if you recall, in this TextureAtlas, it also had the ability to, at runtime, I will grimace every time I say this, runtime to be able to then load an XML file, read an XML file, and then process it to then build those regions more dynamically. So let's show this now. Back to here. So in the tutorial, the example XML I use is this, where, and this doesn't have to be XML. It could be JSON, it could be CSV. I heard a fantastic new element which basically is using dot notation. So rather than all these spaces and commas, we should just use dots. A dot is only so many bytes, and I digress now. It was a funny joke of someone trying to make a joke about serialization, storing content out. Maybe we should use special characters as breaks in files, and then we don't have all this empty space. I digress. It was funny-ish. But anyway, so we've got a standard XML definition. So we're calling it TextureAtlas. We have a property of texture, and then we give a collection of regions. We each the region names in, and so we're going to take this. I'm going to go over to our content project and load up the editor, because why not? Over here you go. And in here, I'm going to create a new item. And we do have a definition for an XML. Oh, and we want to name this. Oh, we have a specific name. One thing to watch out for when you're using this new window is don't put the extension in, because it automatically puts in the suffix for it. So if you create it in the editor, fine, you can put the extension in. In here, don't, because you'll just end up with .xml.xml. Thank you. But anyway, creating our XML, which just creates the definition. If I load this now, it's not going to do anything, man, because it doesn't know what it's going to build it, but there's nothing in it. to blank file. So we're going to look at this in a moment. It's actually doing, and this is what I'm going to come back to later, is that the content pipeline has its own way of loading XML. But in the tutorial, what Chris has done is actually writing a custom definition. So if I update this now and paste it in, what you will find, I shouldn't have closed that. Okay, so with this XML, now the content pipeline doesn't know what it is by default. So it knows what an XML file is and it knows how to process an XML file, but only in the monogame way. So if I now build this, it's going to go, whoa, oh, sorry, rebuild it. There we go. No. Why are you building it? I'm not saving it. No, I should have broken. Well, it's not. Oh, wait, no, because it's not. One thing the tutorial does tell you to do. Well, I've lost my edit. Go to here. One thing the tutorial says to do is for all this XML, we don't use this default importer. We want to actually use. Sorry, no, build action. There we go. I'm going to change this to copy. So instead of the content pipeline processing it, all it's going to do is going to copy it, make it available at runtime. So that should just happily build now doing it, because all it's doing is rebuild. There you go. Cool. Yeah. It's going to effectively copy. It's just copying it into your content folder for runtime use. It's one way to do it. We do this in the 3D platformer. We have JSON files, and in that, we're just copying it into project for use. Anyway, we've got our content in, and then all we're going to do is at runtime, so we're going to load content. Instead of all this now, we only actually need to load this, because what we're doing is we're moved into XML, the regions, what's in it. We also set up where the texture is, and also which file to load. So we'll do this now. So it's using the from file method, which just takes a path of a file. We'll look at here. So we'll look at load file. It takes a path. It opens the file. It loads the XML document. It starts to read it and then process it. And then what it's doing is that for the texture file, it's just going to do load it and then set the texture property of the atlas. It does automatically. And then it's going to walk through however many regions are set up in that XML file. Where are we? So for each of these regions, it's then going to pass the values and the name. It's going to show that they're correct. And then it's just going to use add region to set up a new region in the atlas. Done. So now we have actually made this whole process more dynamic. So instead of, if I need to change the textures or change the images or change their sizes, all I need to do is update this XML file. Makes life a lot easier. And it also becomes more important later on when we're doing it. So now, fingers crossed, when we run this, oh, yes, you got me again. You got me again. But you weren't quick enough. Okay, so I've actually put this in. Where do we put this file? We put this in the root. There. So in this path, where are we? In the game. I'm supposed to put it in the images. I should have created an image folder. I will offline. I'll go back and fix all the folders and put it back. Before then, do what I keep forgetting to is actually committing all the code and pushing it up online into GitHub. So there we go. If we go and run this again, see the audiences helpful audiences are always good. Nope. Why are we still not loading? We broke our XML file as well. You know, no, okay, right. Let's make ourselves, because if I don't do this now, it's just going to break everything else in the entire tutorial. I'm going to put that in there. I'm going to put this into the images folder. I'm going to manually edit this because it's just quicker. So yes, the content project's definition is configuration is just a text file. you don't have to use the editor. If you want to, you can just use edit the text, and it makes life simpler. So okay, we got our atlas there, we got the logo there. Yes, I'll have to go back and make sure I change it. And copy. Don't have to actually do those bits. We'll just double check now if we open this and build it to make sure that I've not done any typos. Oops, rebuild. Yeah, that's all building. And yes, I'll have to go back and then undo what I did. So, so put that there. The XML file is all using the images, okay. And when we're loading the XML, okay, that should be fine. Anyway, she'll follow the tutorial and do what it says rather than just do what I want. So now, even though nothing visually has changed, we've changed how this works so that now the textures and the atlas and the images are all coming from the XML file, which means I can change that XML file and have it work. Now we get onto the extra credit section here. So at the moment, there is a, actually, whoa, there was a question before we do. Okay, so John, we had a question about sprite packing. Can packings, one sprite next to each other, be useful to reduce overall texture resolution, and thus reducing? Yes. So again, less textures that need to send to the graphics card, less texture you need on your device, and at runtime is useful. But it is a trade-off because it then depends upon the quality of your textures. Now, you can also have multiple copies of the same atlas. So you keep the same regions, but the file is of a different resolution, which means you effectively have what we call maps or level of detail, so that if things are farther away, you can use lower grade textures, or you can use higher grade textures. You can also have the same, if you have the same atlas at different resolutions, that helps with things like mobile. So if you have a platform which has much tighter constraints on memory and different things, rather than having to change all your game code, all you're doing is changing the textures feeding into it. Hence, your game is then smaller when it's being packaged. The only thing you need to cater for there is that you would have a content project that's for mobile and a content project that's for Xbox for different size textures. There are other ways of doing it. More ways you can, more things can shake stick at them. Okay, Pixel, but I'll get to your question next, and if I can find your question, we'll come back to that. So yes, but again, as we said in earlier, it's a case of you still have to be sensible at this. You know, if you have like an 8K texture with 8K resolution things, and you're trying to put everything on that one texture, that's still going to be slow because you're suddenly taking one big massive file. So that's when you start to cut things up to make them more dependent on the screen you're going to draw when you're going to use them. And also when you're, you know, the content manager itself is very efficient in how it loads textures off disk and how it saves textures. You still have to be careful. So everything's a trade-off. You try and pack as much in as you can where it makes sense, and you group things based upon how they're going to get used. So for instance, like, you know, the game UI screen, the menu UI screen, you might load and then keep in memory for the entire life of the game because you've got your pause screens, setting screens, all the things there. But for certain levels, it's like, well, you go into this level, this is one biome, right, there's all my textures for that biome. But that's only useful when you're in that biome. So then you might unload it and even unload it from memory, and then load, right, the next biome, I'm going to load that one, and then you're going to start drawing that, and you'll be efficient with it. Right, so that's that. Pixel Bandit. I'm not seeing the question. Okay, yeah, so yeah, Pixel Bandit, if you got a question, by all means, put it in the chat. Or we also have, there's our QR codes, the Code Time Discord chat. So if you're watching the stream offline, or even if you want to answer it now, I've got this open on my screen. I've got to show the right thing. Yep. There is a dedicated thread for each week showing what it is. If you go to here, this is the University General Discord chat, and you can go to the specific thread for asking about a specific week or a specific chapter, or if it's a general question about the whole tutorial, then put it in the main one. I can answer that anytime, not just on stream. So by all means, jump in, get in there and show what you're doing. I'll just get rid of that now, because this thing takes a lot of screen space. Right, so yeah, so Pixel Man, so to do so I don't confuse everyone else. Reply to you directly. There we go. So yeah, we're trying to be as accessible as we can, and let's get in there. You can have the Discord chat here, but text chat is fine. I shall get to more questions later. So, right now, my bee in the bonnet with this tutorial is that we've introduced a problem here. Is that we are copying the XML file. So here's our XML file there, and it's in our project at runtime, and then at runtime, we are looking for this file and loading it. Now, what happens if there's some corruption or something happens to this XML file? And ask away, and what I'll do. Okay, I'll just refer this. Oh. Okay, right. The problem here is the fact that this XML file is at runtime, and if something happens to it, either during the build or even when it's being installed on the device, and that file becomes corrupt, we're now got a big problem there, because we've now introduced something that will only happen at runtime. Or I might have even done a typo, so I might have been in here and then accidentally called this atlas. Now, I might have been testing and building is there, and then I've accidentally done a search replace or change or done something to this file that I'm not seeing when I'm running. And I've created a build, I've shipped it to the store, and now suddenly every single person's game will then crash. And this points to an issue, or something especially we try to levy on with the content pipeline is, if you're working with content, if you're going to do validation of what you're putting in there, move the validation of that as early as possible so that you can test it early. You can test it during build so that before content even gets to your game, you can check what that content is. And the content pipeline has the ability to load XML files. Granted, you do need to have a bit more care, because it needs to be structured in a certain way. You can just write your own, what we call a custom content processor and importer, to handle however you want to do it. And so that what you're doing, you validate and build. And as we go to the newer content builder system, it becomes even easier to do. But so rather than having this texture like this, what you can do is, if you recall, when I set up the XML file initially, it actually looked like this. And I've taken this the ASCII definition file and I've turned it into this. Now, where this is useful here is that you've got this XNA content class, which identifies the content pipeline. This is an XML file you understand and knows how to process. And then in here I said, right, here's a type definition for loading this. And now what this will do is this will create instances of a class using this data. So like we've done here in the TextureAtlas, where we do, we're creating a new region. I'm now doing it in XML. And this will do automatically for it. And this does this at content build time. Now, there are a few caveats to that today. So fine, I've now converted this into what XNA supports, but we need this type. Now, I could have spent time changing this, but I didn't want to change how the whole tutorial went. So I've created a new technical access data class, which also represents it and can use it in pulling it in. And well, the one contention is that most MonoGame projects now are .NET 9. the MonoGame content builder editor is still .NET 8. So to use this, I've created a new class library. So if I look down here, so you can see here, create a new content types library. This is a .NET 8 because I need to use this as a reference point for my content. I'm also going to use this in my .NET 9 client project as well, so which will still work because .NET 9 can be .NET 8, .NET 8 can't be .NET 9. And again, this is just a MonoGame class library that I set up. Look at the documentation for how you would define all these. And then in these, then I created this TextureAtlas content type. And where this becomes important is that, so we get rid of you. Let's just close your dot save. Go away. Hey, we closed it. Oh, we closed it. Come here. Stay open. So we've got our content types, which is our class library, and then we've got our TextureAtlas data definition, which is here. So this using the namespace and lookup. Now this is important for the content pipeline to be able to then deserialize this data. It needs to know what it's talking to and what it's filling in. And in here you can see that I've simply got a name, the X, Y, width, and data, and then it's going to form that into a list. So I've got my TextureAtlas data, so I've got my texture, my regions, so it looks similar to what the texture region class looks like, and I can reuse this data in there. So then now back in the content project, first thing we need to do is add the reference. So we build this types. So this is the data we're going to use. No, sorry. This is still the GCB, not the content builder. Although this is going to be far easier on the content builder. So yeah, we love to move to that, but right now the tutorial is still on the old tile. So once I've built this library, which is containing the types I'm going to deserialize, I'm going to go into the Ghost content project, go down to here, and then I'm going to add a reference to where the built DLL is for that content project. So that one here's the content types in debug.NET 8, and that's the DLL. So this then just lets the actual content editor know what it's talking about. And then in here, I'm going to add existing item, not folder. I done that wrong. Add existing item. I'm going to, on my TextureAtlas as well, open it and this added a link. And then in this, I can now leave the default properties in it because I can leave the default XML importer because it's going to read this XML as, right, I'm a MonoGame XNA type. I am this class. Go and read. I'm going to be this data. So, right. So that's there. Now if I do this and I leave this to actually build. Why are we not building? Just to prove me wrong, it's going to build badly. Oh, save. And also make sure that I go over here, build you. No, the DLL did exist, so build. This is just going to cannot resolve types, content types. Why is this not work? This was working earlier. Okay, so content types, TextureAtlas data. We're in that class. Okay, right, fine. Let's get rid of you. This is what happens when it all goes horribly wrong. So we're still copying that one and that one. And then we added this one. So I'm going to close you, reopen. Okay, so okay, don't know what it is. We're going to add in our reference. So, I love it. This worked perfectly before. I blame stream. Open that. Look at that. And build. There we go. Who knows? So now I'm testing this now. Now, if I break this XML file, if I put in something else wrong, so let's say if I get rid of, or Actually, that's not going to do anything because we're only doing the basic one, so only loading data. No, I don't do that because it's an asset. There, right. So now, in our game, instead of doing this from file, ooh, my screen's going to go off. And what we're going to do is we're going to say, right, we're simply going to load. Okay, I create a TextureAtlas data reference, so I'll go reference to it. And now it's going to simply load this data. And then this gives us an Atlas data reference, which is what all that content is, with all that content. So instead of here. And have we got time? Oh, we're only going a little over time. So now if I build this, we're going with this line. That's going to build. That should still run. Content load, texture path. We moved all the images. So rather than fix it there, yeah, we edited that XML file. So there, I've created a runtime issue. I changed the XML file. It's broken my entire game. So then instead of doing this now, we've loaded our this XML with all the definitions. So let's fix this. So in our TextureAtlas now, let's create a new version. And instead of that, okay, we're going to do here. And we call this a, what do we call this? Atlas data. Well, one bracket too many. Breaking it left, right, and center. Coding on the fly, always good. Okay, it's not returning an Atlas yet. So content manager, and we need a type it right. Oh, it doesn't know because does my content project have a reference to projects? Ah, sorry. Let's make this easier on myself. Different namespace. Game doesn't know about this, which we should do. Oh no, this class doesn't know about this. Okay, we'll call it yes IntelliSense. Okay, and we now add a reference to. Oh no, this is it. Oh, I'm getting code all over the place. So while. Right, okay, so that's because our content type is in here. Our library doesn't know about it, so yes, I'm going to have reference to it. So there, add a project reference to our content types. And now we go to here. There we go. Now it knows where it is. We're not returning it. So this needs to do the same thing as it did before, where it's going to create a new TextureAtlas, and we then want to do that. So copy this here. Where you go, red squiggles? I was in the right place. And then, okay, so we still need to do loading the actual Atlas texture. But instead of just a texture path, we can get the Atlas data dot texture. We could go further in processing and do something else. And then in there, in our TextureAtlas data, we now have got a collection of regions. So then I just need, whoops. And we just need to go for each. Oh, look at that. IntelliSense has done it for us already, and then return Atlas. So now instead of having this at runtime where I'm loading the XML and then processing it and going it through, we're now saying, right, well, we've loaded this file from the content pipeline. We know this file is safe because it's been pre-built. All the content in there is fine. I mean, I would probably go so far as a case of I would actually write a custom importer so that I would even also load this texture to make sure that all the binding of the texture is there. So if I forgot to include the texture in my content, it would then break at build time, not here. Here, the moment if that texture doesn't exist, it's still going to break at runtime. But again, that's more work. So now we want to go back to our game. So instead of from file, whoa, oops, what did I do? We want to do, no, from Atlas data, we need to move this up here. I'm going to specify the Atlas data, there we go. And now, fingers crossed, Now this is simply the most basic thing you can do. So that because my content's now being built in, I've moved, importantly here, all the failure logic and things that can go wrong as far left as possible. So before my game gets to run, I built my content. It's tested everything, it's going to work. So I know that when I run my game, it's just going to work. It's not going to crash because something's missing. Well, it will if I took away the texture. But also, if you try to take away as much logic at runtime as possible so that the game is almost done. It's because if it's given content, it knows to put it to the screen. It's given audio, it's going to play it through the sound card, and so on and so forth. So it makes life simpler. Now I'm running over. I've got tea to cook here. I have dinner. If you're following us on MonoGame, then please give us the whole like and subscribe. If you're on Twitch, then give us the whole bell and follow. Everything helps. It all goes to help support MonoGame. But let's jump into a bit of Q&A. There's the chat for anyone who needs it. I'm going to get rid of that for now because that just takes up too much screen space. Where are we? There. Let's get back in screen. So, over to chat. Where are we? What are we talking about? So we'll go there. Right. So, ethereal regions. Oh, that's a fantastic handle. New to MonoGame. Multi-threading be difficult to MonoGame. Multi-threading is by far the easiest in MonoGame because at the end of the day, it's just C#. There's no engine getting in the way. There's no UI threads, there's macro threads. You are more in control of the project and how it runs. So if you want to do threading, by all means, you can use async in MonoGame. You can use different kind of threading techniques. In some ways that it's recommended, but, and there's always a but, it depends on the target platform you're going to. Now, MonoGame is C# based. Now, for most Windows desktops, it's not an issue. For most Linux desktops, it's not an issue. Macs, if you like it. Once you start getting to consoles like Switch or to other handhelds, then your options become more limited because you're then limited by what those platforms support. So, for instance, on the PlayStation, the .NET version is limited because of how the compilers and things work with that platform. So beware. If you start to do a lot of funky advanced things and different shader techniques and things like that, you must have to take care of what platforms you're going to target. And you're limited by what those platforms can support. Some platforms, for instance, have to use what's called ahead of time compilation. So you're pre-packaging and doing all the binaries for a runtime. So you can't do any subtle checks on things in runtime or do just-in-time compiling because those platforms will limit and restrict it. So yes, depending on what platforms you want to support. Okay, so Pixel Bandit is in chat is saying that he's a good artist for work. Finding a good artist is always a lifesaver. So there, quick shout out on stream. And okay, yes, I love the new content builder, and you'll see I've got many videos and recordings about this. I will do more, I promise, because it's just so much fun. Taking away that editor is a lifesaver. It takes away all the complexities with the project, with dealing with having a .NET tool in your project. Well, there's other recordings for that. I recommend go and view it. Oh, good. Other people have jumped in about multi-threading. Okay. Yeah, I'd say Rob's advice there is brilliant. Use what you're used to. So follow the 2D tutorial. and learn all the basics how it works. Then when we go our 3D tutorial, learn 3D. So many content creators out there I know will say, I want to build the next Quake, or sorry, a bit more, next Halo. Fantastic having dreams and aspirations, but learn the basics. And I do this whenever I go into studios or to universities. Learn the basics first. Build upon your knowledge. It will not take you long because MonoGame makes things easy, very easy and quick. I mean, you can do this 2D tutorial in a couple of hours. I'd probably say take a few days. And then once you've learned it, what I say is that build something. There is no better experience when you're learning all this work is to then try and craft something yourself. You've got a question, something stumbles, go back to the tutorial, look up, right, that's what I did wrong, and build your project. And the other advice I give, and that is why we commissioned this 2D tutorial to be the way it is that finish it. Don't just build a demo. Build it, put menus in it, put the artwork in it, package it up, publish it somewhere. Do the material you're going to have, how you're going to promote it and work it. The last 10% of any project is 90% of the effort, and that is very, very true when it comes to game development. You will learn a lot more finishing a game and actually getting it out in the world than you will just building little demos and tricks and little thing. Oh, I'll try this technique and do it. It's good for learning techniques, but for finishing a game, there's no better experience than just actually shipping it. As long as it works, it doesn't have to be brilliant. No one's going to suddenly come down the banhammer if you're a learner and sort of mess on you just because you're going there. You tell people this is what I'm doing. I highly recommend. And let's see, we've gone to now. So where's my browser? The other thing I suggest. Let's see, it's that one, isn't it? Oh, it's Raspberry. There's something I forgot to show. Oh, you can't see my screen right now, so that's safe. So browser. Yeah, I'm going to switch on in a minute. So on the MonoGame public Discord. Okay, here we go. Go back to screen share. There we go. Right. So the MonoGame Discord is it is by far one of the most helpful communities out there I've ever come across, and I've worked with a lot of communities. There's like the 2D showcase where people are showcasing what they're doing in 2D. Everything from finished projects to little tests and things, and you'll get feedback from the community about how you're doing on. And also the developer diaries, which also people have used this to great levels of showing little progress they've done. People will give you help and say, well, go try here and do this. And that's just all work. There's also all the there's all the tutorials about how people can set things up. Everyone can belt in and help out everyone else in the community. But also then there's also the other things. Work through these, jump in. Everyone is there to help. And yes, there's also the help content builder preview. So if you're all interested in working with the new content builder system, everything you need to know is in there. It is very much a trial by fire element until we get things finalized. Bear with us. Yep, and Dom, who's also one of our MonoGame Foundation members, yeah, we will preach MonoGame because of how good MonoGame is in the community is, but not everyone is comfortable with code. If you prefer to use an editor, yes, you got Godot or you got Unreal or Unity. If you like to do Python, there's Pygame and things like that. We're never going to mandate or dictate what you should code in. We're going to promote what MonoGames works. If you try it, if you like it, great, go ahead and do it. You will learn more about how games work with MonoGame because you do have to build everything up. But there is that trade-off. You do everything yourself. Although I say that this libraries channel here is loads and loads and loads and loads and loads of add-ons and extensions and things you can put into your project to do things for you. But also these are all everywhere in MonoGame you'll find as the source. So MonoGame is open source. If you're not sure how things are working, then go work that. If you want to use Tiled, there's an open source project that shows Tiled. Go ahead, go wild. But yeah, actually, one thing I meant to mention is that if you're curious about loading with XML, there is a full XNA/MonoGame tutorial sample built up around this. This is on the XNA Game Studio Archive. If you look for it, you'll find it. And there's even a MonoGame version updated for doing this. And this is all the source for loading the sample, having all the different types and things. So as you can see, building XML for all these platforms. You can see here, this has got the particle settings. There's the XML file definition and all the properties are in it. We can then look at where the where's the content. There we are. There's the content. And you can see here, this is what shows building XML or content as early as possible helps. So here I've got an XML for an explosion particle system, and there's all the settings for doing an explosion. Then I've got the one for doing fire, and then doing spell. And this is using all the whole particle system in this sample, but all the configurations in XML. So if I want to add more, they're in here, and then I simply call them up at runtime. Off it goes. But yes, go well over time again. One of these days we'll get to time. Yeah. I even though I work for the foundation and my heart is in XNA and MonoGame, for work I need to do everything else. So I do Godot, I do Unreal, I do Unity, and others. I have lots of fun with lots of others. But yeah, this is why I say to each their own. Use the link to the repo. I shall quickly create. In here, we'll go to the home page. It's easier because in here, this archive has got everything that was built for XNA is in here. There's full game samples. There's samples in here. These are mostly in XNA, but there are also the MonoGame-Samples, and since Dom's on the line, he would shout at me for not shouting it. I'll pop 2 links on it. I can't type. I'm typing away and you can't see it still. That's my one. There it is. Right, okay. So I shall put both of these links up on the stream. So there's the XNA Game Studio Archive. This is archived a lot. Now, if you like to, I'll actually point out, if you like tutorials, this series is fantastic. Reimer was a herald back in the days of XNA, where he had a little 2D tutorial, doing terrain, doing 3Ds and HSLs and shaders. These two aren't upgraded yet, but this is great. You can create like a flight set. Let's build an entire. Do I have GIFs on this? No, I didn't put the GIF on this. A little X-wing around a city. Oh, no, there it is. There's the GIF. I love converting that. It's fantastic, and it teaches you everything. Anyway, so let's put these links up here. So the XNA Game Studio. I shall put this near QR code in the stream as requested, because we can do this. So link. So oops. Game Studio Live. Okay, I should put that one on the screen. Where is it? There. Okay, so this is the XNA Game Studio Archive. Loads of XNA, the samples that Microsoft built. And for those that we've migrated over to MonoGame, they're here. But switching from MonoGame to XNA is simply a case of changing the DLL. And all the source as well as zips of all the projects run here. And we would be remiss if we didn't also have Dom's thing. Now, Dom's project's different because this is also all the XNA samples, but these are all MonoGame. Although we do fight hard to make sure we keep these up to date. And these are full samples, simple samples, things like that. So if I go and add this one, so this Dom's GitHub thing. This is another fantastic resource just for if you want to see how something works. Let's get this one on screen. There we go. You want to look at code and how these things. Now, a lot of these are also we also use sometimes as background to the new samples that we're doing. And let's see if I go over here. MonoGame. Go to the blog. We do need to make this more accessible. But if we look here, so if you're looking at all the samples and things, these are things that are in the works that we're building on. So there's the Kenny's 3D platform starter kit. There is also an FPS kit in the process, and again, this is currently available for access to sponsors right now. So if you want the source to this is all available as we speak. As is to the Ascent now. This is a fully. There we go. This is Ascent. This is our now premier 3D sample we're working on. This is available to people at the Cornflower Blue, so it's the higher tier sponsorship access. Full access to the source. There's full dedicated chat for people who are working on this. This is more advanced systems and more advanced shaders and things like that. Constantly evolving and going ahead and doing. Oh, see, don't be maybe well over. Right, so back to chat. Is anything else before we drop off? Anything else anyone else wants? So yes, we've shared all the links. They're in the stream. Oh yeah. Okay. There's a final Q&A. So one of the things I intend to do, especially for the content, you can't do it with the MonoGame content editor, the thing we're using today. Because building content, you need the editor, or you need access to the code that does it. But with the new content builder system, things are more fully automatable, and I will do it. I'm going to do a demonstration of having an entire MonoGame game with the content builder built through actions and automation to then ship a game onto a store. So that when my code is ready, my asset's ready, I will run the build. It will build the content and validate everything that works. If that works, it will then go and build the game. It will then take the content and the asset game, slap them together, package it, and put it on the store. This is the wonder of automation. It's a case of one click, things will just go. And then where this is really invaluable is when you're shipping to testers and how you're going to send things out. It's fantastic. It saves so much time. I use this a lot, especially with Unity and other things, because if anyone was built a Unity project, you're half an hour sitting at the screen watching a progress bar. And no one wants to do that. So I say, right, commit my code. Ooh, code. No, I'll do it later. No, I was going to rework later. When we're doing things from source control, I'm going to pick it up in the next scene because we're half an hour over and I'm going to cook dinner. Yeah, you commit code, push it up to a source control, and then it goes and builds it for you. You can continue working on your project. Nothing's locked up or broken. So, yes, Dom's pointing out that all his code's automatically built. Mine's not. I think it's XNA. But anyway, I always keep talking for ages on this. Right, okay, so that's another university session done. I hope you've enjoyed how to build and optimize textures. And next week, what do we do next week? We're doing sprites, which is taking what we're doing with all the TextureAtlas and regions and then organize it into a more fundamental, useful way of doing things. I'm hoping next week will be quick. But anyway, we'll catch you all next week, and if not, I should also highly recommend going to watch Tom's stream tomorrow, as in see how he codes and things works out. So how did you play that? But anyway, I shall see you all. I know